All right, hi everybody. We're moving on to our next unit, Newtons. We're going to look at forces. So let's start with our first one of Newton's laws. All right. So Newton had 3 laws. You might be familiar with them. Okay, they're very common things used a lot in physical science classes and things like that. But before we get to those laws, let's actually do one fundamental thing. You're going to hear me say the word force a lot. So let's actually get a definition for force. So force is a push or pull. So this is something you do every single waking second of your life, from the moment you're born to the moment you pass away. You are always pushing on something or pulling on something. You sitting down right now, you are pushing on the object you're sitting on. You're standing, you're pushing on the floor. So you're always constantly pushing or pulling on stuff. Okay? And whenever that's done, a force is considered to be applied. Now, a key thing to understand is the way we're going to look at forces is you must be in contact. Okay? If an object is not in contact with another object when a force is being applied, there's no force being applied. So for example, if you're about to throw a baseball, your hand is in contact with the baseball the entire time until you release the ball. The moment you release the baseball, you are no longer applying a force on the ball. Okay, you've already done that. So it's very, very important to understand that once a force is not being applied, once you're no longer in contact with an object, you are no longer applying a force. Okay, so let's get after it. Newton's 3 laws. Okay, so Newton's laws. Number 1. This one's kind of wordy, but it lays a lot of foundation. So the first law states that an object at rest and or an object moving, sorry, I had space there, at a constant velocity will stay at rest or in a state of motion unless acted upon by a unbalanced or outside force. Oof, there's a lot. So an object at rest and or an object moving at a constant velocity will stay at rest or a state of motion unless acted upon by an unbalanced or outside force. This first law, a lot of times, is also referred to as the law of inertia. Those are 2 different things. Yes, the law of inertia could fundamentally be the same as Newton's first law, but they're actually very, very different when we kind of look at the more detailed nitty-gritty approach. Newton's second law, this one is where we're going to spend a lot of our time because this is the math-based law. Okay? So Newton's second law looks something like this. So we have this Greek symbol, capital F equals ma. So A is your acceleration. Units are meters per second squared. M is mass. Units are kilograms. Okay? So A, acceleration, meters per second squared. Mass, this is kind of a newer unit. We haven't done mass yet this year. So mass, base units are kilograms. So let's take a look at this other side. So F, that is my force. Force is given in units of newtons, named after Newton himself, which are abbreviated to an N. Force is also a vector. Okay, so remember, if something is a vector, it has both magnitude and direction. Okay? Now this last thing, this sigma. So I'm running out of room, so long arrow coming. Boop. So sigma, Greek symbol, so now you can add that to your repertoire of Greek symbols, means summation. Or adding of things together. So when we look at the force being applied on an object, we look at all of the forces being applied, of course, along the x and the y axis. And then we can use this general formula to solve it out. This formula, summation of forces equals mass times acceleration. You're going to use this a lot, this unit. A lot. This is like our basics for all of our force equations and how we solve out forces in various things, or the mass, or the acceleration, okay? So get used to using this equation a bunch of times. And we'll do more with this later on, more like tomorrow on the 31st, or on the 1st of December. And his third law, which might be the one you might be able to do verbatim because this one's the easiest. This is what we call the action-reaction law, okay? What that really means is kind of the following. So object 1 applies a force onto object 2. That's my action. I apply a force onto another object. The reaction is object 2 applies a equal force, but in the opposite direction. Okay? So this would be an example of like when it's getting icy out and you slip and fall on the ice. Okay? When you slip and fall on the ice, you yourself have mass. Okay? If you go to Newton's second law, you have a mass. When you fall at some acceleration, probably gravity. So therefore, you multiply these two things together, you then have a force. And you apply a force onto the ice or to the ground. And the ground or ice is like, cool, all right, well, here's that same exact amount of force, but back on you. Okay? That's why it hurts when you fall on the ice. If you've ever like rollerbladed or ice skated and you like ran into a wall or into a door or whatever. Or if you've been unfortunate enough to punch a door or a wall, which I don't know why you would, but if you have, fit of rage, it happens, I guess. It hurts. This is why. Okay? So there's Newton's 3 laws. Very simple, very short. First lecture. Okay, we'll deep dive into this stuff more tomorrow. You guys have a good one.